Hello, welcome to the night class. Today we are going over solving quadratics. So, the first way we're going to solve them is our question here says, why are the x-intercepts of the graph of a quadratic function important to the solution of a related equation? So, before we do this, how would we work that? Just without graphing. We would add 16 over, right? Okay. And then how do we get rid of a square? Take the square root of both sides. And what is the square root of 16? 4. There's also another square root of 16. Negative 4. Okay. We get two answers, right? 4 and negative 4, because 4 times 4 is 16 and negative 4 times negative 4 is 16, right? Okay. So rather than doing it algebraically, which we just did, let's put it in our calculator and graph it. So go to y equals and go to y equals and put x squared minus 16 in there. Let me grab my calculator. Y equals, my calculator's being stubborn. If your thing looks funny, hit zoom 6, and that should fix it. Like I said, hit zoom 6. Why is it not working? There we go. Now let me try this again. Sorry, my calculator was working, but it's not now. So let me. If you hit zoom and 6, it should fix it. Okay, there it comes up. All right, here we go. All right, so y equals x squared minus 16. Okay, and you hit graph. And I want you to notice, what was our answers again? 4 and negative 4. What are our x-intercepts? 4 and negative 4. Okay, it's as simple as that. Okay, so how are the x-intercepts related to the solutions of your equation? They are the solutions. Okay, so I want you to understand, anytime the directions say find the x-intercepts, find the solutions, find the zeros, find the roots, all of those things mean the same thing. Has everybody got me? Okay? So, my equation's answer could be 4 or it could be negative 4. Either answer works. Okay? Yes, ma'am?
Do we need to put x equals in front of it? Or?
Yes. Good question. Yeah, you would need to put x equals, and you can put positive negative 4 rather than saying x equals 4 or x equals negative 4. Okay? All right, let's do their next one. So, try it. X squared minus 14x plus 49. Again, we're just graphing. So graph it. I'm going to let you do it the easy way. X squared minus 14x plus 49, right?
What?
You hit graph. All right. What do you think?
A little funky.
It is a little funky.
Would it be 7?
It is 7. Okay. Any others? No, I'm asking. Nope. Because it only touches at what?
7.
At 7. Okay. So the last problem we had how many answers? 2. This one we only have 1. Keep that in mind. Okay. So
when you're solving,
x equals 7.
How do you know if there's 2 or 1?
How many? Did y'all hear a question? She said, how do you know whether there's 2 or how do you know how many answers you have? How many times does it cross what? The x-axis. Okay? If it crosses twice, you have how many answers? 2. If it crosses once, you have 1. If it doesn't cross, you don't have any. Y'all remember that thing you get sometimes called no solution? Okay? I want you to understand, though, in algebra, it'll stay no solution. okay, it really should be no real solution. Because there are these things called imaginary numbers when you get to Algebra 2 that you are going to learn about, okay? And those are your solutions, okay?
I don't know our numbers.
They're called imaginary because they're not what? They're not real.
So then why are
Okay.
we worried about them?
How does that
They're not real.
Because you do use them later on when you get into more complicated math, okay?
we have to do?
So, you don't have to worry about those. Algebra 1 is strictly only real numbers, okay? So you're only working with real numbers, but just understand there's this whole other group of numbers out there called imaginary numbers that you will get to learn next semester in Algebra 2, okay? Or next year, whenever you take it, all right? Let's do another one. How about x squared plus 3x plus 7? X squared plus 3x plus 7. Plus 3x.
And here is the
Graph. How many times did it touch the x-axis?
zero.
Therefore, what's my answer? No real solution. Okay?
You kind of if we don't say no real.
I won't, because at the moment you don't know there's any other difference. Okay? I'm telling you because you're the advanced class and you can handle that. But you know, if this was just a regular class, I wouldn't even talk about it. All right? It's just no solution works. That's fine. Okay? All right. One more. What are the solutions of the equation? I said one more. We got two more actually. So, do A and B there real quick. What did y'all get for A?
Positive and negative 6.
Positive and negative 6. All right. What about B?
Not there yet.
All right.
Negative 3.
Negative 3 is correct. Any questions? Easy enough? Beautiful. All right.
And so these are always going to equal 0? Like the equation?
That's a great question. Did y'all hear his question? He said, will they always equal 0? Yes. If you are solving them by graphing, you have to set it equal to 0. Okay? And let me give you the kind of sky view, okay? There's a bunch of ways to solve quadratics. This is just one. Okay? Graphing is one way. All right? There's also a thing called the quadratic formula. There's a thing called completing the square. There's something called factoring, which we've already factored, right? Okay? And there's something called just using square roots. I'll go ahead and be honest. How we did it algebraically earlier, where like for this one we just moved the 36 over and then took the square root. That's just taking the square roots, okay? The problem is you can't do all 5 all the time, okay? Graphing sometimes works. Doing square roots sometimes works. Factoring sometimes works, okay? Quadratic formula and completing the square always work, okay? But the other 3 work sometimes, all right? We are going to learn all the ways, all right? This time we're using what? Tables, okay? So I'm not a big fan of using tables because I can just use my graph, okay? But this is how you would use the tables. So let's plug this in to your calculator. Y equals x squared minus 7x plus 6. And rather than graphing, hit second graph and go to your table. Okay? And basically, we want it to equal what? 0. So basically, you just go to your table and figure out where y is what? 0. And for this one, like it says, it's 0 at 1 and what? 6. So my answer is x equals 1, x equals 6. Okay? Easy enough?
Wait, so you plug it in, then you press what?
Second graph to get to your table.
Second.
And then you're just looking for what makes the y 0.
6.
And
1.
1.
1. 1 and 0. Or 1 and 6.
Wait a
Excuse me.
minute. Wait, never mind.
Okay? Now, to me, it's easier just to look at the graph, because where did it cross the x-axis? 6 and 1. Okay? So, it's just another tool in your toolbox. All right? Try that one. 3x squared plus 5x minus 2. Oh, man. Sometimes this happens. Okay?
Wait, Coach, like, this will sound
Yes.
weird, but every time we've gotten to these tables,
Right?
I've always just turned it off to get the blank. Is there another way to do it?
Turn it off. What do you mean?
To clear off the graph.
Clear this off.
Why are you doing that?
No,
Because
to
that's
make
what we
it go
did in the
back to
previous
blank.
problem. It's like, how do you get it off without turning it all the way off?
Just go to y equals.
I've turned it all the way off.
No, you don't have to turn it all the way. Just go back to y equals. All right? Has everybody got it in? Okay. Now, you can use your graph to kind of know where you're looking at. Okay, if you looked at that graph, hit graph for me real quick. How many times is it crossing the x-axis? Twice. But I go back to my table, I'm only seeing what? I'm only seeing 0 once. Everybody see that? But I know there must be another one. Can anybody look at my table and tell me where it might be? Brett says between 0 and 1. How does he know it's between 0 and 1? Because it goes from negative to what? To positive. Well, to go from negative to positive, I had to go through what? 0 at some point. Everybody understanding that? Okay? So, I know one answer is what? Negative 2, because I get 0. I know the other answer is 0 point something. Something between 0 and 1. So, right now, you see my x's? Okay? Let me do this and show you on my calculator. Somebody read that to me real quick. It's 3x
3x squared plus 5x minus 2.
plus 5x
Yes, sir.
minus 2. Okay. So, whoa. Okay, so there's what they had, okay? Now, you see what the x's are counting by here? They're going by what? Ones. Here's how I want y'all pay attention, because this is, you might not need this now, but it's crazy what the calculator can do. If you hit, you see this, what is this? This is the table. You see up in blue above window it says TBL set. What do you think that means? Table what? Settings. Table setup, however you want to say it. Okay? So if I hit second and window, this is my table setup. Notice it says table start. Where's my table start? -3. Yours might be different. It's okay if it is. But I want you to understand what I'm meaning. If I go back to my table, look where it starts at. -3. So say you wanted to check out 100 without scrolling all the way to 100, you could just go to second window and set your table to start at what? 100. And then when I go back to my table, I'm at 100. You got me? Does that make sense? Okay. Normally, you don't have to start there that high. You want it to start around 0. Or like I said, we were at -3. So I'm going to go and change it back to good old -3. Okay. And what's this mean? What's that triangle mean in math? You've seen it before. I'll tell you where you saw it. You saw it when you were doing slope. The slope is something over something.
Rise over the run.
Rise over run. What's another way of learning it?
Y over X.
Okay, you just said y over x, but it's the what in y over the what in x. The change in y over the change in x. That little delta, that's what it's called, the little triangle. Okay? That means change. Anytime you see this, that means change. So this is telling you how much the table is what? Changing by. And ours is changing by what? Ones. So it's going by what? Ones. So if I wanted it to go by 2s,
Is that in the X?
I would change that to 2. That's how much the x is changing. I could change that to 2, and when I go back to my table, It's now going -3 and then what? -1, 1, 3, 5. See, it's skipping because it's changing by what now? 2's. Okay? But I don't really want to make it a bigger change. I want to make it a smaller change. So I'm going to go back and let's make it 0.1. Okay? Second table. Now, let's see here. We knew, well,
Could you just tell the table to start at 0 and then do it by 10?
you can tell it to start wherever you want it to start. Okay? I know -2, 0 works, and I knew it was from 0, in between 0 and 1, right? So I'm looking. All right. A little closer now. 0.3 and 0.4. It went from negative to positive. Okay? So just as an estimate, I know my other 0 is about 0.35 or 0.34, something to that effect. Okay? If I don't want to worry about this, because like I said, I don't really use the table much, okay? As you can see, it can get pretty complicated, okay? Before I forget, though, I'm going to go change it back to 1, all right? So second window, because I really don't want my table changing by something that little, okay? I don't want it by 0 either. 1. Go back. Oh, shoot. What did I forget to change? Now, did I change start? No, that's just where I left off, remember? Okay, I scrolled down, and so it made the start wherever I was. So I need to go back and change that also. We'll let it be 0, okay?
Whenever I try to do it, nothing appears.
Are you hitting second window? Are you sure?
No, I'm talking about when I try to do the graph, the second graph.
Second graph?
Yeah.
Do you have a y equals in there? Jolie, I don't believe you.
Okay.
I still love you. I just don't believe
It's
you.
also an error.
Okay, table start. Where do you want it to start at? You have to tell it where to start. And you lied to me. You don't have anything in there.
Wake up!
There's stuff in there, isn't there?
No.
I can't stand
Two.
I don't know.
Oh, you somehow changed your independent to ask. You need to. They both need to be on auto.
Thank you.
All right. So we're all learning. Let me show you what she was doing wrong.
I did not do that. My calculator did
Her calculator did this. Your auto should be on there. Okay. Don't let ass be highlighted. It should be auto. Okay.
Tell your calculator to not
All right.
switch it.
So, like I said, I did all this just to show you this. I'm going to graph it. I know that one's crossing at what? -2. I'm not sure about this one. Okay? So here's what you do. You remember us finding the maximum and minimum where we had to tell the calculator where to look? Okay? We're going to hit those same buttons. Second, trace. I don't want a maximum or minimum though. What do you think I want out of those first 5? A 0, because I want to know where y is what? 0. So I'm going to hit number 2. It asks me the same questions, left bound, right bound. So I move that cursor left of what? Not left of my vertex. I'm not worried about that. I'm worried about the 0 right there. Okay, so is it left of the 0? This is left of it, yes. It's not very far left, but it's left. Okay, enter. Oops, I hit enter twice by mistake. Let me try that again. So left, enter, move it to the right, enter, enter. 0.333333, which is what? 1/3. That's my other x. So x equals 2, x equals 1/3. Well, just understand, we learned a lot that you didn't actually need on this problem, but you might need it later. Okay? If you're ever not sure about where it's crossing, like say you might, well, it kind of looks like -2.1 there. Okay? If you're never sure, you can always do it that way. And it will give you the exact answer. Everybody good? Okay? All right. let's keep on trucking. Approximate solutions, here we go. This is what we're talking about. Anastasia. That's a good movie if you haven't seen it. Hits her golf ball off the tee. The height of the golf ball is modeled by the function f of x equals negative 5x squared plus 25x plus 1, where x is the number of seconds after the golf ball is hit. How long is the golf ball in the air? Okay, so how long is our time, right? Okay, so she hits it, and as it's in the air, time is what? Time stop. Time is going. Time, nothing stops time. Okay, time is ticking. So she hits it. Time is ticking. Okay, I'm measuring two things. It has time, and it has what? Height. I'm looking for what? How long is the ball in the air? I'm looking for what?
When it hits zero.
Time. Okay, time from what? Time until it does what?
Goes for it.
Touches the ground, and when it hits the ground, what is your height?
0.
0. So basically, you're just figuring out the x-intercepts. Okay? So if I go to graph this, negative 5x squared,
I don't remember this.
negative 5x squared, what was it, plus 25x?
Oh, it's in the book. Plus 25.
Plus 1. And I hit graph. There's my golf ball. Okay? It went way high and came back down. But I'm not worried about how high it went.
Good night.
Yes, ma'am.
Hey, I need to have Madison Eubanks come to the office.
Yes, ma'am. She's on her way. So I'm not worried about how high it went. Where was it on the tee at?
0.
At the origin. Where did it hit the ground again? Over here. Okay? It looks like 5. But to be sure, I can hit second, trace, 0, make sure it's to the left. In this case, the left is what, above or below it? Would left be above it or below it? Above it. The right would be below it. Enter, enter. So was it exactly 5?
How does that work?
But mine said that wasn't right. Yours is wrong. Like, so you did left bound?
Left bound is above your point.
How is left bound above? Because you have a back. If it's minimum, then left would be before.
All right, look at me. All right,
It says error. No,
there's my cursor, right? You would agree it's to the left of this point right here, right? Okay, so everywhere above that point, it's still what? It's still left of it. So I'm still, see, it comes back. As soon as it goes below that point, now it's on which side of it? It's on the right. Okay, so you have to be above the point to be left and below the point to be right. Is it always like that? No. If it's going this way, it's going to be backwards. Okay, if it's going up, now to be above it, well, let me think. Oh, no, I'm sorry. This one is,
I don't know what's going on.
no, left would always be above it. Now that I think about it. Left is always above, right's always below. Okay? Oh, you know what? No, I'm wrong. That's not always. If you're talking about the point on the right, left is always above, right's always below. If you're talking about the point on the left, they're swapped. Okay? Anyway, about how many seconds was the ball in the air? 5. From hitting off the ground to being back on the ground, about 5 seconds. Okay? Everybody good? All right. Let's do another one. Again, here's our words. What type of answers can we have? How many, I should say, if it's a quadratic? The most we can have is 2. The least we can have is what? 0. And there's, of course, one solution in the middle. Okay? So, listen real close. This is all the solutions you have. So if you ever get 3 solutions for a quadratic, it's wrong. Okay, that's not possible. Okay, it can either be 2 solutions, 1 real solution, or 0 solutions. Okay, zeros of the function are the what intercepts? The x-intercepts. Okay, that's also called solving. Whatever, like I said, all that means the same thing. Okay, you can solve it using algebra. Okay, using your graph or using your table. Like I said, do I use the table much? No. Do you see why I don't much? Okay, because everything you need is on the graph. All right, any questions? All right, y'all have a great time doing your work. See you next time and hope you stay above the line.